Thank you. So I'm going to talk to you today about authentication and also Angular and putting them together. So a little bit about me. Juan kind of said all of this already, but I run a couple of DevRel teams at an identity and access management company. I'm a Google developer expert in Angular, and I also run the Angular Ann Arbor meetup in Michigan. Now, when it comes to authentication, I saw this tweet earlier this year, and it seemed to ring true for a lot of people. Basically, a lot of times people's experience with authentication is they come on, they're gung-ho, ready to go, they start working on it, and then it ends up looking something like that. So I want to kind of demystify this a little bit for people. So I'm going to start out with an introduction to authentication for web applications, and I'm going to talk about both classical traditional web apps as well as single-page web apps. So the first thing I want to talk about a little bit is cookies. So cookies are traditionally used with server-side web apps, so apps that you might build with PHP or .NET or Node.js. And the flow for this looks something like this. You have your browser, and then on the server you have your back-end web app, and maybe it has a database. Now when the user submits their credentials to log in, and if it's successful, then the server is going to set a cookie in the browser that represents the user's session, and therefore the user is authenticated, and our web app knows it, and the browser also knows it because it's got a cookie. Now, on subsequent requests for pages, or whenever there's traffic to this domain, the cookie is attached by the browser and sent to the server. After it does this, then the requested page HTML and any sensitive data will be sent to the browser, and the user can view it. Now, if the cookie expires, or there is no cookie, and a request is made for protected data, then a 302 redirect status is going to be returned. And what this is going to do is going to tell the browser to do a full-page redirect to somewhere where the user can re-authenticate. Now, once they've done that successfully, then the application can send them secure data once again. Now, in single-page applications, we see a lot of use of token-based auth instead. So now I'm going to talk a little bit about how this works. It's a little bit different. So we have our browser, and then when the user navigates to our application, the app is actually compiled, downloaded, and then it runs in the browser itself. Now, we usually get data from an API, not necessarily our own API. It could be, it also could not be. And then we would get tokens probably from something called an authorization server, and this is really kind of just a fancy word for a set of endpoints whose purpose is to issue tokens. So the user is going to submit their credentials to log in. If everything checks out, then the authorization server issues a token back. And so the token is then going to be sent to our API with any requests for data. The API is going to verify the token with middleware. And then if everything works out on that end, then data is returned as JSON, which the app consumes. So here's a question. Why wouldn't we just secure our single-page app and our APIs with cookies, just like we do with traditional web apps? Well, one reason that we don't see this a whole lot is because cookies only work on the domain of the application. So if everything's on the same domain, then that's great. Cookies will work for you in this case. But a lot of single-page apps actually call APIs that live on other domains, or if they don't right now, maybe they need to scale and do so in the future. And if your API is on a different domain than your application, that same cookie is not going to work. So maybe you don't have this problem. Some people don't. If everything is on the same domain, then you probably should consider securing your app with cookies. What you want to do is probably think about putting the authentication layer in your backend, because you own your own backend, and then do app authentication with routes served from the backend, and then use cookies to secure the data that's moving in between the SPA and the backend. There's one thing that you do have to keep in mind, though, if you do this, and that is that when an application uses a cookie-based session, so a traditional web app, and the user tries to access a page, if they're not authenticated, remember they're going to get that 302 redirect status. And this is going to redirect the entire browser to somewhere that the user can re-authenticate so that a cookie can be generated. Now, single-page applications request data using AJAX calls. So if your cookie is expired, then the response is going to be a 302 redirect, the same as in the other example. But in a single-page application, we need to add logic to handle that 302. We don't necessarily know, if we're expecting a JSON response, we don't necessarily know what to do with an HTML page that says 302 on it. So you can handle that case, handle that status, and there's really no problem with doing this, and you can do this. However, on the other hand, if you know that you need to scale, or you already have APIs that are on other domains, then you are going to want to take the token-based authentication approach. So if you're going to need to do cross-origin stuff with your APIs, then use tokens. So about tokens, a token is a very powerful artifact because the bearer of a token can access your secure data, right? So where do we store tokens? Well, a lot of times, historically it's been recommended that we put them in local storage. We actually shouldn't do this because local storage has a distinct lack of data protection. The concerns that we need to keep in mind when we're using local storage or something like this is that it's vulnerable in a number of ways. So first of all, any JavaScript running on the page has access to local storage. So a cross-site scripting attack, if you have a malicious script or a compromised third-party script, it can read the local storage object and steal all of its contents. So any user info, any sensitive data, any tokens you put in there are basically up to grabs if you're a victim of an XSS attack. The other side of that, cross-site scripting can also access local storage and put malicious data into it, which can potentially make it somewhat untrustworthy of a source. And then finally, all local storage is shared within a domain. So if you have multiple applications running on the same domain, then all of those applications can access the same local storage object. So they could read each other's tokens and things like that if you had different authenticated apps on the same domain. So now the most common reason that we put tokens in local storage is session persistence, right? It's so that the user still has a token if they leave the application and then come back, because we don't want to make them re-authenticate all the time if they just happen to hit the refresh button. So what can we do instead of putting our tokens in local storage? Well, we want to store our sensitive data in application memory. And then when the user authenticates, our authorization server, that set of endpoints for issuing tokens, can set a cookie in the browser that represents the user's session. Now, note, this cookie isn't sent to the API or anything. It's just the knowledge of what the user's session state is with the authorization server itself. So if we go and do something like refresh the browser and lose all of our local state, and then we come back, our app reloads and we don't have our token anymore. But what we can do is we can use that cookie to check the session and see if the authorization server session is still valid. And if it is, then we can actually request new tokens silently without prompting the user for credentials, because the authorization server still knows about that user and has a knowledge that they are logged in and have not ended their session. So that kind of brings us to some more guidance for using tokens with single-page applications. A little bit of a history lesson here. In 2012, when the OAuth 2 spec was adopted, single-page apps were not mainstream. So for example, AngularJS came about around this time, but it didn't really become popular until 2014, and this is after OAuth 2 was adopted. So historically, the guidance for doing authorization with browser-based applications was to deliver the tokens to the browser in a hash fragment in the URL. Now, there's some inherent security risks with doing it this way. The token is actually vulnerable in a number of places. So you have it in the redirect URI, because you're redirecting the token to some URL that you are assuming is owned by the browser, or I'm sorry, by the application. But if that redirect URI was hijacked, then you could be sending your token to somewhere else. In addition, it's accessible in the browser history, which is also accessible to JavaScript running on the page. And it's also potentially accessible in the referrer header. So if you are under attack and a malicious page is requested right after authentication takes place, then the attacker can look at the referrer header and just grab the token right out of there. And finally, the last thing is the app doesn't really know where the token is coming from. It just sees it in the URL hash and it uses it, so it doesn't have a way to necessarily verify if it's coming from a trusted source or if it was injected maliciously from somewhere else. Now, Authorization servers and app developers who implement authentication actively work to mitigate these risks right now. So this guidance has been around for 7-ish years, and there's no new threats to this approach. So these same mitigations are going to continue to work. I'm not telling you new things because all of a sudden there's a new vulnerability. There's not. So I want to make that very clear. But because modern JavaScript is eating the world of web apps now, it's really just time to recommend new practices. It's time to have our recommendations be a little bit more secure. And don't worry if you can't get all these links. I'm going to have a link at the end that has all of the links in it. So the approach that we're recommending now from the IETF is the same approach that's actually used in mobile applications already. So it's not exactly a new approach, but it's new to the world of browser-based apps. And in this scenario, we basically exchange a code for a token. And it works something like this. I'm going to go over this a little bit quickly, but don't worry too much about it. So the first thing that we need to do in our application is create a random string called the code verifier, and this is a high-entropy random string. Next, we're going to compute another string from the verifier using a hashing method, and that hashing method is called the code challenge method, and it gives you something that's called the code challenge. Now, when the user logs in, the credentials and the code challenge are sent to the authorization server. The server then returns a code, which is received by the browser in a hash fragment, and this is fine because interception of this code isn't dangerous. The code by itself can't actually be used for anything. It can't grant somebody access to something if they were to steal it. But once we have the code, then we take the code and the code verifier and send them to the authorization server. Now, what we can do is we can recalculate the code challenge from the verifier, and then we want to make sure that the challenges match the one that was sent by the app earlier and the one that the verifier that we were sent, where we recalculate the challenge from the verifier. If the challenges match, then a token is issued as a JSON object and sent to the application, and it can consume it. Now, all the mitigations for the security risks that I talked about with having the token in the URL, we don't need those anymore if we do this other approach. And this seems like kind of a lot, right? It's several steps to take. There's, a hashing method involved, and you exchange a code, blah, blah, blah. But really, don't worry about this too much because SDKs can handle this for you. So ultimately, if you're building a new application and you need to add authentication to it, then you should probably consider using this new approach. It's just more secure, requires fewer mitigations, but if you have existing applications that use the token in the URL approach, as long as you're mitigating the risks that I talked about, there's no new threats that you have to worry about. So you don't need to sort of run out and freak out about, oh, all of a sudden my app's not secure anymore. It's just as secure as it was probably when you built it. So that brings me to sort of the next half of my talk, which is how does Angular help us with authentication? What tools does Angular have as a platform and features that help us to secure our apps? Well, I'm going to do this by making a little bit of a to-do list here. One thing we want to be able to do is elegantly manage authentication events. For example, token availability or the login status of the user. We want to be able to send the token to the API with API requests. And then finally, we want to be able to restrict access to certain routes. So managing authentication events. We have an awesome library that comes with Angular that helps us out a lot with this, and that's RxJS, of course. So what we can do with RxJS, for example, is we can bind callbacks from external libraries and turn them into observable streams. So as an example, maybe we're using an authentication SDK, and it might provide a method that returns the token data from our authorization server. And maybe it's a node library, so what we can do is we can use bind callback, or in this case, bind node callback from RxJS to create an observable that emits when that callback completes. So you would want to use the appropriate method for the type of SDK that you're using. But then we can subscribe to that, and we can do something with the authentication data once we receive it. And we can also pass options to the bound SDK method on subscription if we need to. Another thing that we can do is we can create our own streams. So we can create streams of things like token availability, user info, login status, things like that. So for example, here I'm creating a stream for user data, and I'm basically just using a behavior subject. And then when the user data becomes available from, say, my authentication SDK and interactions that I'm having with my authorization server, then I can tell the stream to emit values. After that, I can subscribe, and then I can take some action when the information changes or becomes available or is not available anymore. So these are just a couple of examples of how RxJS can help us to manage authentication data and callbacks in our applications. And I'm sure that you can find a lot more ways to leverage RxJS with authentication in your apps as well. So if we come back to our authentication to-do list, we learned that we can elegantly manage authentication events by using RxJS. And the next thing we want to do is we need to send the token with our API requests. So Angular, as of version 4.3, which thankfully is a while back now, has HTTP interceptors. And these are used to transform requests or responses. So when we call our API, what we can do is we can intercept requests using an interceptor service. We can attach the authorization header with the token, and then we can send the request on its way. So in order to implement this, in our app routing module, we would take a look at our providers array, and we want to provide HTTP interceptors from Angular Common. Then we want to tell it what interceptor service class that we're going to use, which I'll show you in a second. And we can set multi to true, because you could potentially define multiple interceptors, and they're just going to be called in the order that they're provided. Now our interceptor service file might have something that looks like this in it. After we do some necessary setup, we're going to have an intercept function. And then in that function, we can do something like clone the HTTP request that's coming through. And then we can set the authorization header with the token on the cloned request. And then we can send that cloned request with the new header onto our API. Now, there's not actually sort of a default way to only run interceptors on specific requests, but we can just use conditional logic in our service. So we can clone and modify requests based on some condition that we define. For example, maybe our endpoints that are secure have the fragment in them that says secure, and we can check for this and then only clone if it's necessary. And if we aren't hitting a secure endpoint, then we can just send the original request on its way without doing anything to it. Another useful thing that we can do with interceptors is make them asynchronous. So you may want to do this, for example, if you, right after authentication, you come back to a page and the page automatically makes API calls that are supposed to be secured. Now, we want to make sure that the token's actually available in our application and our application knows about it before we fire off a call, because we don't want to send a request that has an authorization bearer undefined as our token. So we can use RxJS to do this. We can wait until the data is available before we clone a request and before we attach the header. So if we have a token stream, for example, maybe created with a behavior subject in our authentication service, then we can ensure that the token is present in the application. We can filter the stream for expected token values. So the token will always be a string. We don't want anything falsy like null or undefined. And then we can set the token once it's available. Now I'm using merge map in this example because this will ensure that if you have multiple requests, that none of the requests that were sent previously are canceled by a new request coming through. So going back to our to-do list, we now found out about how we can use interceptors to send the token with API requests. So the last thing that we need to be able to do is restrict access to certain routes. We do this with route guards, and route guards actually implement 3 different interfaces. The most common, most well-known one is CanActivate. And CanActivate prevents unauthorized users from navigating to a route in the UI. But the thing is, the code is still downloaded in your application. So although the user won't be able to browse to the route, they could potentially look in your code bundle and see everything that it is supposed to be in the route. So you would never want to put secure data behind something like this. It's really just for the presentation layer. Now, CanActivate child is very similar to CanActivate, except that it prevents unauthorized users from navigating to all children of a specific parent. The last interface is called CanLoad, and this one's a little bit different from the previous two because it prevents lazy loaded modules from downloading in the first place if the user is unauthorized. So if we take a look at our app routing module, we're going to want to set up some routes, and here I just have an example using a profile component. We can use the interface name as the property, and then we can have an array of multiple guards, and they will be called in the order that they're listed. So for example, a CanActivate authentication or route guard might look something like this. It's going to implement the CanActivate interface. So it's going to return a CanActivate function which returns an observable, a promise, or a Boolean. And this is going to tell the application whether navigation should be allowed to proceed or not. So inside our CanActivate function, we can do something like this. We can, for example, deny access based on some condition that we define. So if my authentication service has a property or a getter called isAuthenticated that just returns true or false based on whether the user is logged in or not, then we can use that, and if they're not logged in, we return false, navigation cannot proceed to this route. Now we could also take some action here. For example, we could redirect to a login page if we wanted to. And then if the user is logged in, then access to the route should be granted, so navigation is allowed to proceed. Now, we can also do guarded lazy loading, and this is when, again, we asynchronously load sections of our application only for authorized users. So it still holds true that you wouldn't really want to put sensitive data directly in your app bundles regardless. Sensitive data belongs on the API. But with guarded lazy loading, you do get the benefit of smaller bundle sizes, for example, as well as some added protection. So let's say that we have a whole section of our application that's lazy loaded for admins only. So normal users or editors would never need to download that whole section in the first place. So this is a really useful way to make sure that the code is only loaded for people who need it and have access to it. So in our app routing module, when we set up our routes here, and I'm using the admin module example, we can lazy load a routed module. And as you saw in the keynote, the syntax for this is going to change in Angular 8, but it looks like it will migrate it for you, which is awesome. But that's going to move to imports. In any case, we can add a CanLoad route guard. And in this case, I'm adding something called role guard. So it's going to check for the user's role to see whether or not they have the appropriate access level. And then I'm going to add some route data, and this informs the route guard what I expect. So I expect the user who's trying to access this module to have a user role of admin. Now we can do this with other guard types or any route-specific data. I just happen to be using the route data in this particular example. But then we have our CanLoad role guard file, and it's going to return a CanLoad, and we're going to tell the lazy loaded module that it can be downloaded if CanLoad returns true. So we can maybe check our authentication service might have a check to determine if the user has a role that we pass in. So if the user has role of the expected role that we set on our route data, then we can grant or deny access appropriately based on this. So if we come back to our list again now, we learned that we can use route guards and lazy loading to restrict access to certain routes, and now we've basically finished our list. So for the first half of the talk, I basically covered some authentication basics. I talked about best practices, and then for the second half, we sort of covered strategies to implement authentication in Angular, ways that the Angular framework actually makes management of this type of data more simple to use. And you can grab the slides and all of the links to the resources, all the links that were at the bottom of the various slides here. And I really appreciate you giving me some of your time today. So thank you very much.